Hello, everyone.
Come. You are listed.
Yeah, it's alright. So we're here today to talk about the OpenStack
Closer to the mic.
on Aarch64 journey. And we have with us Marcin. I'm not going to pronounce his surname. Juszkiewicz from Red Hat, Samir Goel from Qualcomm, and myself from Linaro. We are all
Gema, Gomez or?
yeah, I'm Gema. I'm the tech lead in the SDI team, and we're gonna talk a bit about what we do. Today we're gonna introduce ourselves and our team and tell you guys what we do. We're gonna talk about our OpenStack goals, what we've done so far since we started back in Liberty, and
3 years ago.
yeah, and what we're gonna be doing next. Our team is called Software Defined Infrastructure, and we focus on any OpenStack, any open source project that is about infrastructure. So basically we're touching OpenStack, Ceph, and DPDK at the moment. We also have containers in the radar. Thank you. Our goals in OpenStack are making sure that OpenStack runs smoothly on Aarch64. And also making sure that OpenStack is fully tested upstream together with Intel. So we want to make sure that they are both feature equivalent, essentially. We do have Aarch64 OpenStack clouds in production in 3 different zones. So we are essentially consuming our own packages and eating our own dog food. So I'm going to hand over to Marcin, who is going to tell you the story of all the fixes we've been doing since Liberty, essentially.
Hello. So Liberty was more or less 3 years ago. It was the first version we used in so-called production. The first version of Developer Cloud was using it. It was working for some definition of working. Networking was based on some hacks. There was no other access for external people than here you have IP of your VM login. No OpenStack access as to API, etc. And it was working, was painful, but it was something. So we were able to give access for people. Then finally Mitaka arrived. It was the first version where we had finally some UEFI support. We could give VMs to people like, here you have VM, it will run whatever kernel you have in it. So people had more control of it. And we still didn't run any tests on them, more than, okay, it works. So for us it's fine for now. And we were able to get rid of all those network hacks we had and just use the Neutron like it should be. That was quite good thing. We had also finally automation for it, so deployment wasn't doing all the manual steps where everyone will forget what the step 3 is, etc. And we moved to Ceph, so we had shared storage, live migration could work, and then came Newton. Newton was the release I liked most from those. We moved from crazy ways of deploying and providing software to some crazy packages. It was supporting, we were supporting at the time CentOS and Debian, then we stopped supporting CentOS because of Linaro changed rules. We did more testing of libvirt, and it was a time when we deployed all 3 clouds at that time. And it was also an interesting moment when we started doing testing and Gema brought us to the IBM Interop Challenge. It was the 25 or 15 different companies with different cloud deployments, etc. Everyone got the same set of rules to deploy and test on their clouds, and we were the only non-x86 ones. And we didn't fail. This was good. And then was Pike. Between Newton and Pike, there was Okata where we did nothing. More or less, we were working on getting our Newton working better then. And we decided that our solution for deploying OpenStack is something we have abandoned because maintaining it took us more time than we had, where we prefer to work on getting OpenStack running better, not our obscure way of deploying OpenStack to work better, right? So we looked at upstream solutions. We found that they have this thing called Cola, which is, let's do OpenStack as a set of containers. It's a huge amount of containers split into some crazy ways in some moments. And I got the goal, get our stuff working with it. So I took someone's patch to add power support into Cola, split it into parts, removed ugly parts, added Aarch64, and after a few months and 50 versions of the main patch and about 30 other patches, we got Aarch64 support working in Cola and PowerPC 64 Little Endian as an extra bonus. We also moved to LibVirt 3.x. We are using 3.8 or 3.10 at the moment. LibVirt 3 made things much easier because this was the release where they moved to use PCI by default on Aarch64, and things just started working magically. And we are also running tests as normal people do, and as a part of our testing infrastructure, basically. So, but we never did deployments with Pike. It was just the completely development release part. But then came Queens, and Queens got released less than a month ago. We have our support. We have Aarch64 supported in Cola. We have Aarch64 supported in Cola Ansible, which is their deployment method to deploy the whole OpenStack on all-in-one node, multi-node, and whatever scenario you would like to do. And we did several nice changes in Nova, like, for example, UEFI support, which was there since Mitaka, is now default on Nova. So no longer you have to type this image has to boot with UEFI, and then do that for all images, which can be painful when you give access to external people, and they will just upload image and then complain, oh my god, my image doesn't boot. Have you said HW firmware type to UEFI? No, you have to. And now they don't have to, which is nice. We don't have to set up any CPU model stuff, for example, for Nova, because Nova does it properly for us, which is not still proper, but that's the thing to work on. And we have graphical console. If someone used virtual machines on remote hardware, then when you don't have serial console, you don't have anything, the only thing you see is, oh, the machine booted like this, but when you have no way to log into machine, the only way you do is, okay, scrap it, play with image outside, upload it, hope it will work. With graphical console, you can at least usually can log in, so that's a good part. And we had several other changes in several components. And then we did one nice thing, which is Aarch64 resources for OpenStack CI. And this is a part where Gema knows better how it goes than me.
So essentially, our goal is to have every single project in OpenStack tested on ARM64 before the patches merge, because right now we're playing catch up with upstream. So for that to happen, you need to give them a way to run tests on ARM64, and we are using our developer cloud for that. We've added 8 nodes at the moment, and they are starting, or they've changed all the tooling so that it can build ARM64 images, so that it can actually interact with our cloud, and we are almost ready to start running jobs on it. So that's going to be the next thing on the next cycle. And now I'm gonna introduce Samir and let him talk about how they use what we've done at Qualcomm.
Thanks. I'm Samir Goel. I'm an engineer with Qualcomm. I'm an engineer with Qualcomm Data Center Technologies. I have been a part of the Linaro SCI team as well for the last couple of months. I'll just reiterate from the user I'll just reiterate from the user perspective whatever Gema and Marcin just said in the last 2 slides. So OpenStack is a very useful platform for us, for multiple reasons. One of them is that it's a good way of running some enterprise level use cases very easily. The biggest problem we have faced till now is it is very difficult to deploy. It's on ARM64 the code is just not matured. It takes the process is time consuming, and if you ask a question to someone, should I deploy it, and they ask, okay, how badly do you need it? So as compared to what happened on the Queen's release, the deployment with Goel has become very predictable. It is less cumbersome, and that I feel is a very cool feature that came out in the Queen's release. So over the next few months, we are thinking of testing this a bit more, see how far it goes, and of course there are still some missing features which I was going to talk about next.
Thanks. Thank you, Samir. So this is what's next on our pipeline. We're going to be fixing live migration. So live migration is an interesting one. It used to work until Queens, but in Queens they decided to make Nova cleverer and make it understand features of the CPUs, which Kevin very kindly implemented for ARM64. But now we have the issue that the entire stack is not exposing those features to Nova. So Nova doesn't really know how to live migrate VMs from one node to another because it doesn't really get the features from the CPUs. So that's something we're going to be fixing in the next cycle. We are working on solving the PCI hot plug issue, which is we were running out of pluggable slots on VMs very quickly because it wasn't properly done on libvirt. Or no, I wasn't using libvirt properly, rather. Marcin has worked on that, and we have a patch. I think we're still going to be... It's in Rocky, yeah. Well, it's in the next release. But I think we're still going to be debugging making it a bit better, a bit nicer. We are testing the VM lifecycle because when you test OpenStack with Tempest, with the upstream test suite, you don't really run VMs for very long. But we are finding out that when you run a cloud in production and you start running VMs for a long time, you want those VMs to live, over a period of time. They're not that easy to manage, and they start degrading, and things don't work as expected. So we are working through some of those issues as well. We're going to keep adding capacity to OpenStack infra. So we're asking our members for hardware for that, so that more projects can actually have test cases running on the gates, and so that we can actually convince people that it's worth trying to make their test pass on ARM64. And then we will be helping them, because most of them don't really know how to approach the subject. So since we have the experience and the people within Linaro, we will be talking to those projects and helping them get started. Am I missing something?
No.
Can I ask what the
No.
Mumble, 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 recording, mumble.
It's working.
Can I ask what the PCI issue is?
Sure. Sure. The thing is that ARM64 is PCI Express machine, and libvirt treats it in a way that it adds PCI port per whatever device it needs, and then it adds 1 or 2 free slots. And you can have plug as many cards, as many free slots you have. So on normal, let's say normal PCI, normal x86 VM, which is PC from 90s, you have automatically 31 slots because it's just normal PCI machine. On PCI Express machine like Aarch64 or x86 Q35 you have just 1-2 slots available. So I wrote a patch to Nova which allows system administrator to set, I would like to have, for example, 25 slots. And then VM starts, it gets 25 slots. Some of them are taken by disk, storage, video, etc. And then you have about 20 slots available. So you can hot plug as much as you want, basically. Normally, you put up VM, you add another network card, another network card, and then you gave a message, sorry, no free PCI slots left. If you want to add anything else, you have to cold plug.
Okay, and that's using the standard virtual machine model as well,
yes.
Right? The RHEL based one.
Exactly.
Okay. Because whenever these things come up, I think the other thing to do is to feed that back into the folks defining these machine types to tell them.
I spoke with LibVirt guys,
okay.
And this was basically agreed with them because I went first to them as, guys, can we just add more slots by default? But then they thought, sure, we could add that, but it should be done by upper level.
Mm-hmm.
Because Nova knows how many slots they have. I had the issue first when I was adding graphical console, and with graphical console the problem was that Nova by default, if you enable graphical console in Nova, it just goes and I have to add USB tablet to have input device, graphic card, and I'm done. But on Aarch64 you don't have USB host controller. That's why when you enable graphical console, you get the message, no free USB ports, and start wondering, what the hell, right? So I spoke with LibVirt guys, and they told exactly the same. It's the upper layer job. Because if they add USB host controller into LibVirt, then it will be in LibVirt 4.1, right? So I will need to bump Nova LibVirt requirement to the latest and greatest which no distro has.
Mm-hmm.
It's that, okay, Nova, let's just add what is needed.
Okay. Let me ask one other question then that raises the graphical console piece. Is that fully solved now, if I want?
Yes.
And how is
graphical
it solved?
console is working. The only thing which was needed was adding USB host controller and USB keyboard.
Okay. And now, so if I do a fresh install and I go in and click on a node, I bring up the console, I'm going to get the GUI the same as x86.
Exactly. Like there was a screenshot on my blog.
Good. Is there anything else missing for x86 parity that you can think of at a high level?
Live migration. Basically, live migration is missing. The thing is that on Aarch64, user space doesn't have any idea what CPU it is running on and how compatible it is with CPU in the machine next to you. So at LibVirt level, I can migrate from XGen1 to XGen1. At Nova level, it refuses even XGen. So this is a thing I plan to debug in next weeks.
That's a regression. The only reason that's happening is because they made Nova cleverer. It used to work because Nova would migrate to wherever. So it just it would find a node and it would try.
And the migration might fail underneath.
And then they try again on another one. Yeah, they would try up to a few times.
So now Nova is saying it's looking at the CPU information.
Yes.
So this is where I'm going to capture this just for the recording. This is where a number of us have been asking the ARM kernel community for the past 2 or 3 years to clean up proc CPU info and enumeration of CPU types and properly fix this, and there's a political minefield and landmine there. I don't care. This still needs fixing, and we need to fix it. Thank you.
The thing is, it's not only Nova, it's also LibVirt, because we had quite old LibVirt, which was telling, okay, it's a host CPU basically. So each machine had CPU type host. So
host master.
yeah.
Okay.
Any other questions? Anyone?
So I want to try this right now. Sorry. Okay.
It's all right.
Sorry.
All right. So we want to try. If we want to try out where you are right now, say with an Ansible recipe or something like this. What's the fastest way in like 5 lines to just, if you have an ARM server in front of you, what do you do?
I'm not sure it's 5 lines, but you could go to Cola and follow the instructions to install an all-in-one node
Okay.
deployment,
Okay.
and then use the images that we're about to produce because the repos froze last week, so we haven't still produced the image. The images we're going to produce, and it will deploy an all-in-one node for you to try whatever you want. Queens. It has libvirt, our version of libvirt in there,
Yeah.
so you won't have to worry about compatibility with the underlying OS or anything. So
So if someone wants to try this out,
yeah,
and spin up a node on bare metal, what's the best thing that people should do here?
Should first get the ERP distro. You can start from that point, and we can provide the address for the Docker repo that you want. As Gema said, the best way is go to just Google for Cola Ansible,
Right.
and just follow the instructions there. And the all-in-one should actually, all-in-one is actually a turnkey. It should just work out of the box. So once you guys have the tag, so I think that tag is something that you probably need to publish or send out somewhere.
Can we work with? I'm just thinking out loud here, but can we work with Packet to make this a one-click thing, so that anyone who wants to try it out can just hit a button and do an install?
I'm sure we could, but I'm not sure we are the right people to do that.
Right. But I mean, what I'm keen is for people who are here, sitting right now, to just be able to go and, click a button and spin a machine up. So
I just have no idea how Packet works.
Yeah, so I'm more than happy to.
Microphone.
you can have a mic. You can have this mic.
I have such a loud voice, I don't need it.
There you go.
I'm more than happy to pull the Packet guys in. They're going to have to do a whole bunch of the work to actually do that.
Oh, sure.
But I'll get that started, and we can do. It'd be Ed with the works on ARM, and then I think they've got about 4 or 5 guys who are working on ARM project stuff. So.
'Cause I know they have Ansible scripts already, so
Yeah.
it'd be nice.
I mean, the thing what I want them to do is use the upstream project Ansible
Yeah.
scripts, not.
The thing, basically to deploy, once you have a host running some Debian stretch, we are basically limiting ourselves to Debian stretch. Once you have remote machine with Debian stretch, or you are logged into that machine, you have to clone Git, Cola Ansible Git repo, take the inventory, the all-in-one inventory file for us Ansible, which is there. Just add on which machine you want to deploy, because by default it goes to localhost. And then run Cola Ansible with few arguments. It's like there is a bootstrap servers which will install required dependencies, pre-checks which checks is there anything running on this machine which will interrupt our process, deploy, then post-deploy which will generates shell file with all environmental variables for OpenStack shell access, and then you run tools run it once shell script which is using the OpenStack shell access to add flavors, fetch zeros image, set up networks, etc. And at the end it gives you, if you want to run the simple VM, just copy paste this and you will have VM.
Let's make that a nice Ansible recipe, and let's put it so someone can get a packet,
Yeah.
click a button, and off they.
Basically, it's written in quick start part of Goel Ansible documentation.
Yeah, but well, as Martin said, we'll work with them and make it make it happen. Yeah.
This is easy, we can get it done.
Good.
All right. I think we're out of time. Thank you very much, everyone, for coming. If you need to talk about anything, just find us.
Yeah, and you're-